treated equally. No fast lanes, no slow lanes.
Not enough news.
Federal Communications Commission, FCC Chairman Tom Wheeler, recently introduced rules that would permit ISPs like AT&T, Comcast, and Verizon to block or restrict internet traffic by creating fast lanes for those who can pay for preferential treatment, leaving the rest of the internet stuck in the slow lane, in slow motion sickness.
Additional supply
This proposal would violate the principle of net neutrality, which requires ISPs to treat all traffic equally.
Not enough news.
Public pressure, which you may have heard of, to adopt strong net neutrality policies has intensified since the federal court struck down the Commission's previous rules in January. The court ruled the FCC could adopt net neutrality protections, but only if it reclassifies ISPs as common carriers, thus preventing them from discriminating or interfering with network traffic. So common carriers, which we'll get into in a bit, is a term that was created in the 1920s around phone lines, that you couldn't say give better or fast phone service to people who paid more. It's sort of the same way that the post office works, in that it costs the same to send a package 2 doors down as it does to send it from Florida to Alaska. And so the idea is a common carrier is not allowed to discriminate in terms of pricing. So I have a background as a software entrepreneur, and so I'm pretty down with the tech stuff, but I'll try and give it to you in a way that makes sense, hopefully. So when you're looking to find an ISP, you're looking probably at its bandwidth to cost ratio. How fast is your connection going to be, and how much you're going to have to pay for it?
Not enough
But
news.
there are a few additional considerations which you kind of need to understand to get the net neutrality question. So bandwidth is the number of bits. All computers run on binary, 1 or 0. So these bits are atomic data blocks that are either 1 or 0 that can be transferred over the ISP network. Now, I mean, it's sort of think of the matrix, right? Everything is a 1 or a 0, sort of scrolling around in that green text. The same kind of thing. Everything that I'm doing here, my visuals, my audio, the text on the screen is all based on a 1 or 0 that combines to numbers and audio and all that kind of stuff, to colors and so on. A 100 megabit download data plan would allow you to receive a maximum of 100 million bits per second, depending on where the data is coming from. So let's say that you can max out your download speed to a particular content provider. Well, you're always going to get the speed you pay for. Well, no. I mean, if you go to your, there's lots of things that can test your internet speed, and it will usually rate a little bit lower. To maximize the efficiency of their network, ISPs oversell the amount of bandwidth they can provide. Is this cheating? Well, not exactly, because if you imagine, like if every road had a dedicated lane for every driver who used them, I mean, obviously, if we were all the president of the United States, this would be inefficient and very expensive. Although network systems are much more complex, the principle is the same. You can't build maximum amount of potential data use for each customer because very few customers use the maximum. There's usually kind of an 80-20 rule that 80% of the bandwidth is used by 20% of the customers, although I think in the world of internet service providers it's more extreme, like 95% of the data is used by 5% of the users. At least it used to be that case. Now there's stuff like Netflix and other data-intensive programs. It's changed a little bit. So ISPs usually do a statistical analysis of their networks to determine what contention ratio is appropriate for their user base. And that's the ratio between actual bandwidth and potential maximum demand. So if everybody, for instance, logs on to watch the Super Bowl over the data line for a particular internet company at the same time, everybody will get dropped frames of dropped balls. And this is a traffic jam. This is called network congestion. And it's sort of similar to airlines, right? Will oversell seats because a bunch of people usually never show up for a variety of reasons. And so that's one of the ways that you keep costs low, is to not max out building for everything. So like real roads, where you've got on-ramps and off-ramps, networks are comprised of interlinked nodes. And so if you imagine physically, if everyone in a city decided to go to the same shopping mall at the same time, all the roads leading to that mall will get jammed. Say if I was doing a speech there. Well, that would of course happen. And if the entire user base of an ISP wants to reach a particular content provider, say free domain radio, the network will become congested and download speed will be incredibly slow. And this actually happened. So last year, I was on a podcast with Joe Rogan, and we went to #1 on iTunes, and everyone was trying to get the podcast from my server in California, and this meant that the server got so congested, people trying to get that particular show, that it took like 4 or 5 hours to download, and people were getting frustrated. So we since then have hosted all of the Free Domain Radio Philosophy podcasts on a variety of servers with a router that routes the demand to the least busy server, and that's all fixed that. So multiplicity is efficiency in the network world. So ISPs often apply very complex algorithms to reroute connections in order to alleviate possible congestion. But there's only so much they can do, right? So if the carrying capacity of the network as a whole is exceeded, so when you want to go downtown, let's say you live in the suburbs, you want to drive downtown, then you will probably check the traffic using Google Maps or some sort of TomTom GPS system, which is going to tell you how congested the roads are and will offer you alternate routes. When the carrying capacity of an ISP's network is exceeded, the only solution is to expand the network infrastructure to create more of these series of tubes that the internet runs on, or to reroute through another ISP's network to borrow somebody else's capacity. Now, there's this concept called peering, which describes competing ISPs connecting their networks for the purpose of sharing traffic between the users of each network. So if you send an email, and you're on Yahoo, you want to send an email to someone who's on some other kind of system or other kind of network, they will share information, right? It's the same thing like if I go to Florida and I want to make a call on my cell phone, then I don't have a contract with the Florida cell phone provider, but they allow the network traffic to pass between my home carrier and the one in Florida. So this kind of sharing is important. And it's the only way it really works. Like if you want to create an entirely proprietary system, then it's not going to work that well because people don't know in advance the system of the person they want to send an email to.
Not enough minerals.
So this is typically a voluntary arrangement, this sharing of data between ISPs that provides ISPs with a number of benefits just beyond shared user access. They can achieve better performance, they can distribute larger amounts of traffic, and even negotiate emergency aid. So DSL, boy, back in the day, I remember my first 300 baud modem back in the 80s, I think it was. And we kind of topped out at 14.4 or the rare 28.8. But now you have DSL. They built on top of telephone wires. But broadband internet traffic is generally carried over the cable television infrastructure. And one of the things is sort of a preview of the challenges we're going to face when talking about government regulation is the FCC spent years and years and years fighting cable television infrastructure because, back in the day, kids, what used to happen was carrier pigeons would carry VCS tapes from one house to another. Actually, it would just go over the air, right? You have antennae, rabbit ear antennae or something like that, which you generally get struck by lightning while attempting to adjust during a storm. So it used to go over the air. That used to be everybody's TV. And then it started switching over to cable, and the FCC fought the imposition of cable vigorously and vociferously, based, of course, because the people who were sending signals over the air didn't want the cable to come in because it was too competitive. And now I think only 7% of Americans get their signals over the air. The rest of them get through cable. So if the FCC had won, you'd have no broadband internet because there wouldn't be a cable television infrastructure with which to carry the data signals. Again, this is the stuff we'll be talking about in a bit later. So what are the major concerns with regards to net neutrality? Well, ISPs like AT&T, Comcast, and Verizon claim that large content delivery networks like Netflix are responsible for congestion on their networks, crippling bandwidth and incurring rerouting costs. Of course, if you're going to borrow someone else's network, you have to pay more for that than if you're using your own network. So, with the advent of data-intensive streaming services, and you can, of course, stream Netflix in high definition, which is just bandwidth monstrous, and a whole bunch of people do that. When Orange is the New Black comes out, or House of Cards, or some particular Netflix original series, everybody wants to see it right away, and you just get this massive congestion, which is a huge problem for the ISPs. So, the ISPs are proposing the idea of fast and slow lanes. So content providers like Google Video or Netflix or Amazon Video, basically it's mostly video. Audio is much less bandwidth intensive. These ISPs propose these fast and slow lanes. So content providers like Netflix will pay for access to the fast lanes while all other traffic will be carried through the slower lanes. because they have to build more capacity, and to pay for that capacity, they either have to charge the consumers or they have to charge the providers. Now, as a guy with sort of 20 years of, more than that now, 25 years of entrepreneurial experience, if I was running a cable company, I would not want to go to the users and say, listen, if you want decent or fast Netflix access, you got to pay us $15 more a month. Because they'd say, well, wait a minute, but I'm already getting it okay. Why am I being charged more? And it's like raising taxes. You know, with the Laffer curve, you raise taxes and people just change their behavior to reduce the paying of taxes. And so you can't just multiply $15 a month by your existing subscriber base, because other people will just leave, right? And so you may end up with actually less money. But if you can charge Netflix for the building of the additional network infrastructure required to stream high definition video to 10 billion people, then the consumer gets a better experience, and they don't see any increase in the price of their cable. They may see an increase in the long run, or maybe even the short run, in the price of Netflix, but that's something that the cable company doesn't have to worry about. So I doubt that the Netflix prices would go up, but it's something that's really important to understand. So what do these fast and slow lanes look like in practice? Well, whenever the ISP's network receives a data packet, it inspects it for an ID. If the ID corresponds to a content provider that's paying for the fast lane, then it will deliver the data through its optimal node path. Terrible name for a punk band. All other traffic would be diverted through the lower priority lanes, making the delivery speed slower. But you may not notice it if it's something as innocuous as a web page, which, you know, is tiny amounts of data compared to even 30 seconds of a high-definition Netflix video. So the delivery speed will be slower, but the reality is it may be faster than if the fast and slow lanes are not developed. Because the fast lanes means that all the data-intensive stuff is routed away from the network that handles things like even podcasts and web pages and email and stuff like that. But if they all have to share the same data path, everything will probably be slower. But if you can divert the traffic away, the more data-intensive traffic away from the slower lanes may actually end up faster.
Close to a promotion.
Like if a whole bunch of people decide to take helicopter rides to